So as a review from last year, oxidation-reduction reactions are any reactions where both an oxidation takes place and a reduction takes place. You can never have one or the other happening. You always have one thing being oxidized and everything being reduced. And this is really a transfer of electrons from one electron cloud to another one. So oxidation is losing electrons, reduction is gaining electrons. And the way to remember it is Leo goes grr. L-E-O, losing electrons, oxidation, grr, gaining electrons, reduction. Now, that's a nice silly one to remember. An easier one might be oil rig, O-I-L-R-I-G. Oxidation is losing, reduction is gaining. Whichever one works best for you, go ahead and use that one. But remember, the thing that's being oxidized is undergoing oxidation. The other thing is oxidizing it, right? It's making it get oxidized, so it's the oxidizing agent. The thing that's being reduced is the oxidizing agent. The thing that's being oxidized is forcing the other one to be reduced. So it's the reduction agent. The thing that's being oxidized is the reducing agent, or the reduction agent. Keep all those things in mind. And what we have to do is put in the oxidation numbers to see which thing's being oxidized and which thing's being reduced. As you go through the notes here, there's a couple quick tips I can give you to try to remember that. So here's an example of a typical redox reaction. Solid sodium metal plus chlorine gas makes sodium chloride, the ionic compound. Now anytime you have an element, a plain element in its natural form, becoming an ion or becoming part of a compound, that's automatically a redox reaction. So the elemental sodium is losing an electron. Each elemental chlorine atom is gaining an electron. And so electron is being transferred from sodium to chlorine. This is a redox reaction. So sodium goes from oxidation number of 0. Remember, an element in its plain, pure, natural form has a number of 0. And in an ionic compound, it has the same oxidation number as its charge. Sodium takes a +1 charge, therefore its oxidation number is +1. Chlorine takes a -1 charge, that means its oxidation number is -1. And what that means is that sodium lost an electron. It loses a negative, subtract a negative, you get a positive. And chlorine is gaining the electron, so it's going from 0 to -1 because it's gaining the electron. Now take a quick look here. Is sodium being oxidized or is sodium being reduced? If we go back to our definition before, oxidizing is losing electrons. Reduction is gaining electrons. Now it seems backwards. You think reduction should be losing electrons, but look at the numbers. This is where it's important. Oxidation, the number goes up, so from 0 to +1 in this example. And reduction, the number goes down. Chlorine is being reduced from 0 to -1. If the number goes down, it's being reduced. If the number goes up, it's being oxidized. The other big hint is that metals generally get oxidized. When they go from pure state to combined, they get oxidized. Nonmetals, when they go from pure state to combined, they get reduced. This slide just confirms what we're talking about. Leo, lose electrons, is oxidation. Grr, gains electrons, is reduction. Now, if sodium is being oxidized, which agent is it? Well, it's the agent for the opposite thing. Sodium is being oxidized. It's giving away an electron. You can think of it as forcing an electron on the chlorine. So it's forcing the chlorine to be reduced. So if sodium is being oxidized, it is the reducing agent. It's forcing the chlorine to be reduced. On the flip side, if chlorine is being reduced, you can think of that as stealing the electron from the sodium. So it's the oxidizing agent. It's forcing the sodium to become oxidized. Now, which is really forcing the other one? It all kind of happens at the same time. One doesn't really force the other one to happen. In this case, there are cases where you have things that are very strong oxidizers or oxidizing agents. They will force something else to be oxidized. Very strong reducing agents will force things that otherwise wouldn't react to become reduced. But in this case, sodium and chlorine are both so reactive that they're kind of equal partners in this reducing and oxidizing. So here's a quick review of the oxidation numbers. Elemental form, always 0. And remember, things that are diatomic, that are naturally 2 together, and that would be nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. If those are like N2, O2, F2, Cl2, I2, Br2, those are always 0 with their oxidation numbers. If it's a monatomic ion, one atom ion, the oxidation number is the charge. Oxygen is almost always -2 unless it's peroxide. In that case, it's -1. Peroxide is the O2 ion. Hydrogen is +1 with nonmetals and -1 with metals. Fluorine is always -1 when it's combined. That one is always the rule. Now 6 and 7, when you're figuring out the unknowns, the oxidation numbers have to all add up to make a neutral compound, so it's 0 for the oxidation numbers. So the oxidation number times how many there are, plus the oxidation number times how many there are for the anion, will have to add up to 0. And this comes into play when you have something with 3 atoms or more. Usually you'll know the outside 2, and you'll need to solve for the middle one, and it's just simple algebra. What's missing to make this all add up to 0? Now, if it's a polyatomic ion like sulfate or hydrogen carbonate, you'll have to figure out the outside ones, and instead of adding up to 0, it adds up to whatever the charge on the ion is. So for sulfate, SO4 2-, you've got the 4 oxygens, each with -2, that's -8, but it has to add up total to -2, so total charge for the entire ion is -2. So sulfur would be +6. +6, and the 4 -2s for oxygen totally add up to -2, which is the charge of the ion. Now what I want you to do on this sample problem is pause it before each one, so we can take a look at what they're actually going to be. So right now pause and use the rules we just looked at to try to figure out the oxidation numbers for H2S. Okay, the rule for hydrogen is it's +1 with nonmetals, -1 with metals. Here hydrogen is with a nonmetal, sulfur, so it's going to be a +1. We have 2 +1s, so 2 hydrogens, 2 +1s, so that's a +2 on the plus side. This has to add up to 0 overall, so sulfur would have to be a -2 to cancel that out to make it up to 0. 2 +1s and a -2 add up to 0. So the oxidation number for sulfur is -2 in this case. Pause it and look at S8, elemental sulfur, see if you can figure out the oxidation number for that. Alright, you should have come up with it being 0. I gave you the big hint, it's elemental sulfur. It's not combined with anything else, it's just sulfur. So the electrons are all where they're supposed to be, they're not shifting around anywhere, oxidation number is 0. All right, for the next one, sulfur dichloride, use the rule for Cl, chloride, and then solve for sulfur. Go ahead and pause it and see if you can figure that out before you start it up again. Okay, chlorine is in the same column as fluorine, and so we're going to call that -1. That's what it would be as if it were an ion. We have 2 -1s, so it's a -2 on the negative side. So sulfur is not going to be -2 like it was in the first example. It's not going to be 0 like it was in the second example. Sulfur has to be +2 to make the chlorides, to cancel out the chlorides. So if sulfur is a +2, each chloride is a -1, that adds up to 0. That's what we want. For the next one, sodium sulfite, use the rule for oxygen that we looked at in the rules, use what sodium is as an ion, and then solve for sulfur. Go ahead and pause it to try to solve that on your own first. Alright, if we use our rule for oxygen, oxygen is usually -2, so I've got 3 -2s, that's -6. Sodium as an ion takes a +1 charge, so its oxidation number would be +1, so we have 2 positives. So I have 2 positives, +2, plus the unknown sulfur, plus a -6 for oxygen. And we need sulfur to be something to make that all add up to 0. It's going to have to be +4. +2 minus 6, we need another +4 to make it add up to 0. So in this case, sulfur will be +4. Sulfur is really versatile when it comes to oxidation numbers. All right, and the last one is a sulfate ion, and we just talked about that. Go ahead and pause it, figure out use the rule for oxygen, the normal rule for oxygen, and then figure out what sulfur is going to be. All right, if each oxygen is -2, that's the rule. I've got 4 -2s, so that's -8 on the negative side. I need sulfur to be some number that will make the whole thing add up to -2, because the charge in this is -2. So sulfur will have to be +6. +6 and -8 all adds up to -2, which is the charge of the overall ion. We can stop here. This is the notes for today. If you want to go on to the notes for balancing redox reactions, you can do that, and we'll talk about that in class the next day.